Hi friends, this is Prabhu, Assistant Professor, Department of ECE from RMD Engineering College, and in this video we are going to see about the dynamic characteristics of a transducer. So in the last video we have seen about the static characteristics. So static characteristics in the sense both input and the output does not changes with respect to time, and or in the other sense we can say it as they are time invariant. So that is a static characteristics, and the opposite to that is the dynamic characteristics, where the measurand is going to change in a dynamic manner. So this is going to be little bit complex than the static characteristics, because the measurand is going to keep on changing. So we have to introduce linear equations. So from the figure we can able to see over here, dynamic means that something is changing with time. So say for example, if you take a 10-day weather forecast, so here if you compare 2 days, here you can see it is 75 degree and the lowest is 57. Here it is 74 and 52, then 75, 52. So each one is varying with respect to time, the temperature and the possibility of rainfall. So everything always changes with respect to time. So that is what being called as dynamic signals. So dynamic means that something is changing with respect to time. So how we are going to measure the dynamic characteristics? So dynamic characteristics relates the response of the device to the variations of the measurement with respect to time. So ordinary linear differential equation with constant coefficient is the most widely used mathematical model to study the dynamic response in the form. So ordinary linear, we all know that is differential equations with constant coefficient is most widely used for mathematical model. So what is dynamic characteristics and how it is being characterized? So if you see over here, the dynamic characteristics of any measurement system is described by four important parameters. They are speed of response, then response time, measurement lag, and fidelity. So this is the four basic concept behind this dynamic characteristics. The speed of how far it is responding or how sensitive it is to the change in the input. So if you see the first parameter, speed of response, it is defined as the rapidity with which an instrument or measurement system respond to change in the measured quantity. So when somebody is touching us, so we could able to feel that immediately. So that is what being called as the speed of response. And the second one is the response time. So how much time it's been taken, the time elapsed between an input is applied and the time in which the system gives an output corresponding to some specified percentage. So example, 95 percentage of its final value. So this is what a simple example. The time elapsed between an input is applied and the time in which the system gives an output corresponding to the some specified percentage. So normally when somebody is touching us or somebody is talking from left side of us, we used to turn left side. So the time taken for us to turn to the left side is generally called as the response time. So this is a basic example. This will be varying from machine to machine. Okay, and the third one is the measuring lag. So there will be a lag or a delay in the measuring parameter also. An instrument does not immediately react to change in output. Measuring lag is defined as the delay in the response of an instrument to a change in the measuring quantity. So whenever there is a change, whenever there is a response, it should be measured. So that is the purpose of a transducer. So there will be some delay in measuring. So that is generally termed as the measuring delay or measuring lag. So there are basically two types of measuring lag. So retardation type. In this case, the response of the instrument begins immediately after a change in the measurement has occurred, and the time delay type means there will be a delay, so which is called as dead time. In this case, the response of the system begins after a dead time, that means after the application of the input. So there will be a time lag in the time delay type of measuring lag. And the last one is the fidelity. So fidelity, is a measurement system, is defined as the ability of the system to reproduce the output in the same variation of the input. In this, so if you see in fidelity measurements, there is no time lag or phase shift between the input and the output. So fidelity means a quick response. Whenever some input is being changed, automatically the output will be changed with no delay in the time period. So normally that is called as the fidelity. So these are the 4 parameters that define the dynamic characteristics of an transducer. And thank you.